For the lesson here, we will understand and use piecewise function. A function that is defined by two or more equations over a specified domain is called a piecewise function. So such function would look like this. This is an example of a piecewise function. And as you see here, this is defined by three equations over specified domain. So the function here, f of x, is equal to 2 if x is less than or equal to -4. And it is equal to the absolute value of x if x is between -4 and 4. And it is equal to x plus 1 if x is greater than or equal to 4. Now for this particular example, we want to evaluate the piecewise function at the given values of independent variable. So first, let's evaluate f at x equals 4. So x equals 4. If x is equal to 4, then you have to look at the domains, the specified domain here, and see where you can find 4. So as you notice, you would actually find that on the third equation. So your function is defined as x plus 1 if x is greater than or equal to 4. So that means that the function here at f equals 4, at f of 4 is 4 plus 1. Because you would have to follow this definition here of the function because 4 is contained in this interval here, in this domain here. So f of 4 is equal to 4 plus 1, which is equal to 5. Now, f at -5. So -5. -5 can be found on this interval here. Now we know that because of the definition of the function, it says here if x is less than or equal to -4 and -5 is on that interval, the function it says here is equal to 2. So that means f of -5 is just equal to 2. Now f of -1. Now -1 is contained on this interval here that is in between -4 and 4. So in this case, the function is defined to be absolute value of x. So this is just equal to the absolute value of -1. The absolute value of -1 is 1. So f of -1 is 1. For the next example, we are to graph this piecewise function, and we would use the graph to determine the domain and range of the function. So let's discuss first the definition of this piecewise function. So the piecewise function is defined as x plus 2 when x is when x is less than 1. And it is defined as 2x plus 1 if x is between -1 and 3. Now, how do you graph this? To graph this, we will create a table. So let's create a table first. Let's consider first the inequality or the domain wherein x is less than 1. So this is x, this is 1. So less than 1, that means to the left side of 1. Now, this one here is just a line. Okay, so we know that to graph a line, we would need at least 2 points. 2 points determine a line. So the 2 points, when you are to graph your line, and it's in a piecewise function, I suggest that you use one of the endpoints here, the endpoint here. So x would be, we'll start when x is equal to 1. Now, if x is equal to 1, the y here will just be 1 plus 2, which is 3, because we use this definition here. So again, when x is less than 1, this piecewise function is defined as x plus 2. So that means f of 1 will just be 3, 1 plus 2. Then the other point, you pick another point that is within this domain here, so at less than 1. You can pick 0, or you can pick -2, or any point in here. So let's pick 0 because that's the easiest. And then we will evaluate the function at x equals 0. So at x equals 0, we will have 0 plus 2, and that is equal to 2. Then you can have another point if you want to. So maybe let's just have -2 here. So -2. So when x is equal to -2, so you plug in, you replace x here by -2. So you have -2 plus 2, and that gives you 0. Now, let's plot these points here. So when x is equal to 1, y is equal to 3. Now, we will make that open because there's no equality here. So it's open. Now, when x is 0, y is equal to 2. When x is 0, y equals 2. When x is -2, y is 0. And then you connect these points here. Right? So that's part of the graph of that piecewise function. That's the graph when x is less than 1. Now, when x is between 1 and 3, so between 1 and 3, the graph, the piecewise function is defined by this line here, 2x plus 1. So since it is, again, a line, so we have y equal to 2x plus 1, that is still a line, then we would just need 2 points also. 2 points because 2 points determine a line. And then since the interval here is between two values, okay, so from -1 to 1, then we would use those points, 1 and 3. Now, when x is equal to 1, then you use this definition here. You plug in your x here. So that's 2 times 1 plus 1. That is equal to 3. And then when x is equal to 3, you have 2 times 3 plus 1. That's equal to 7. So when x is equal to 1, we know that y is 3. So that makes this one shaded now. So that's part of the graph now. And then when x is equal to 3, that's the last point, y is 7. So you have 7 here. And then you connect those 2 points. So this is now the graph of this piecewise function here. Looking at the graph here, we see that the domain is from -infinity up to, it's only defined up to x equals 3. So it's only up to 3, and that's included. Now the range, that means the y values. So we have graph from -infinity. So, because this one would continue. So that means it's from -infinity. Now, you always start with smaller numbers. You always start with negatives or -infinity. So -infinity going to, the last point is this. It is 7. So it is only up to here. So it is -infinity to 7, and 7 is included. That's the range of this piecewise function. So for this next example, we are given a piecewise function defined by this. Now first, we want to find f of -1, then f of 1 and f of 2, and then sketch the graph of the function. Okay, so f of -1. -1. Now you see both -1 here, but the second equation contains the equality. That means -1 is included in this interval here. So there should be x here. So x is greater than -1. So that means we will use this definition of the function to evaluate f at -1. So we have -1 squared, and that is equal to 1. Then, next, evaluate f at 1. Where can you find 1? 1 is contained on this interval here because x is greater than -1. 1 is greater than -1. So therefore you use x squared. So therefore you have 1 squared, which is equal to 1. Then f of 2. F of 2. F of 2, again, that is also on this interval here. So 2 squared is equal to 4. I'll add another number. Say, for instance, what is f of -2? F of -2. F of -2. Now, -2 is less than -1. And that is defined as -x. So therefore, we have negative of -2, which is +2. Now, if I add another one, f of -4. F of -4. -4 is contained in this interval here. And that is defined as -x. So -4, if x is -4, your function is -x. So you have negative of -4, which is equal to +4. Now let's go ahead and sketch the graph of this function. So to sketch the graph of the function, we would need to compartmentalize it. So let's graph it first over this interval here. Let's look at -1. So this is -1, and that should be less than -1. Now, this is just a line, because that's -x. So it's a line. We only need 2 points when we will define a line. Or we would also use our knowledge on the basic function. Okay? So anyway, because this is just a line, we would need 2 points. So we can use -1 as our point. So we have, if x is -1, this is your x, f of x. So we know if x is -1, if x is -1, we know that that is equal to 1. Well, using here, also that's equal to 1. Using this definition here, you replace -1 at x. So negative of -1 is 1. And so you have negative of -1 is equal to 1. Then also pick another number that is contained on this interval here. We already did that here. So we can have -2, and that gives you 2. And also we had -4, and that gives you +4. Then you connect all these points here. So when x is equal to -1, you have +1. So initially, this is not included, because that's not included in the interval. And then when x is equal to -2, we'll continue here. And then when x is equal to -4, it is equal to 4. -2, -4, it's also equal to 4. Then you just connect the points here. Okay, that's a straight line. Let's make it straight. All right, now for x greater than -1, we have this parabola here. We know that it would look like this. So the curve here, the graph would look like that for x squared. Okay, so also here, when x is, so for the second part, which is x squared, f of x equal to x squared, you know that the graph would look like that. and we plug in values here. We would also start at -1, okay, just to make sure that the two graphs will connect, or if they don't connect, they will have different values. So x equals -1. From here, from this definition, we have seen that if x is -1, we would get y equal to 1. And then another point, well, we know that it will pass through 0 at the origin. So if x is 0, you plug it in here, 0 squared is equal to 0. And then another point, we've seen that if x is equal to 2, this is equal to 4. So 0. And then if x is 2, it is equal to 4. Then you connect. So again, this is here. That's now defined. Okay, so this is how the graph of this piecewise function would look like.